So this question asks us to find currents I1, I2, and I3 in the circuit here. And we're going to do this with the mesh current method. So to apply mesh current method, what I need to do is label mesh currents, which will be little circular arrows, for example, as I've drawn here, IA and IB. And I usually draw these in the same direction, so it's kind of convenient to get into the habit. So I'm going to draw them in a clockwise direction. Now, the relationship between the mesh currents and the currents I'm trying to find, we can examine that, we can kind of read it off the circuit. So it should be pretty clear to you the current I1 is equal to the current IA, and it's a positive sign because the arrows point in the same direction. Same thing for I2, so I2 is equal to IB, again positive sign because the arrows are pointing in the same direction. But when it comes to I3, if I actually look at this branch, I see that there's two mesh currents flowing through it. So I kind of get a combination of both, right? There's a contribution due to IA and there's a contribution due to IB. So looking at the direction of the arrows, I see I will have positive contribution from IA and a negative contribution from IB. So the way that I see that, IA arrow and I3 arrow are pointing in the same direction through this 10 ohm resistor. But if I visualize this IB arrow kind of continuing around its circle, you see it goes in the opposite direction through the resistor than I3. So because these two arrows point in the opposite direction, I put a minus sign over here when I'm writing down what is my I3. So the meshes are really partial currents. These are sort of some elements that make up the total current, and the total current will be some combination of each of the mesh currents. So next step is to apply Kirchhoff's voltage law on this circuit. So if I do Kirchhoff's voltage law at node A, mesh, these are meshes, at mesh A, then this is what I will get. So I choose an arbitrary point as where I will start, and I proceed in the direction of my current arrow. So I will first encounter a negative 100 volts. Approaching from the bottom, I get the negative sign of that source. Then I will get this resistor, and I can use Ohm's law here. So Ohm's law tells me that this voltage, V equals IR, so current times resistance. So resistance is 4, current is IA, so I always use the mesh currents. Then I come across the 10 ohm resistor, and here the current through this 10 ohm resistor is a contribution due to IA, and also a contribution due to IB. And of course we have a minus sign on IB because when I'm doing KVL, I have been going in a clockwise direction around this loop, whereas my IB current will be the opposite way with respect to that 10 ohm resistor. So at this point I'm back to where I started, so this is all equal to 0. I can now simplify, clean this one up just a little bit. So I will collect like terms. This will give me 14IA minus 10IB, and that is equal to 100. And so I will call that equation 1. So my next step is to apply Kirchhoff's voltage law at mesh B. And so I do that. Again, I choose an arbitrary starting point. I might as well pick, let's say, the corner over here. And I proceed clockwise direction around this mesh. The first component that I encounter is my 10 ohm resistor. Ohm's law here tells me I will have 10 ohms multiplied by the current. The current will be in my direction of travel IB minus IA. My meshes are opposite with respect to this resistor. The next component I encounter is a 5 ohm resistor. So that is 5 times IB. Then the positive terminal of that 40 volt source. And now I'm back to where I started, so that is equal to 0. Simplifying this expression a little bit, I will have a minus 10 IA plus a 15 IB is equal to minus 40, and all of that I'm going to call equation 2. So now I have a math problem. I basically have the two equations, two unknowns. So I'm going to write this in matrix form. So expressed as a matrix reading off my coefficients, from my first equation I have 14 minus 10 IA is equal to 100. From my second equation I have minus 10 15 times IB is equal to negative 40. So now I can solve this system of equations. I'm going to do this using Cramer's method. You could, of course, solve this using one of the other ways of doing simultaneous equations, but I kind of like Cramer's method, so that's the one that I'm going to use. So in order to use Cramer's method on this system, I need to evaluate some matrix determinants. So I need to know the determinant of my A matrix. A matrix is this one here. So the determinant of my A matrix is the determinant of 14 minus 10 minus 10, 15. To evaluate a determinant, recall we do kind of diagonal products. So I will have 14 times 15 minus the product in the opposite diagonal. So the product in the opposite diagonal is a minus 10 multiplied by a minus 10, and I just get out my calculator and evaluate that. So determinant of my A matrix is, 14 times 15 minus 100 is 110. Then I need to know, for each of my variables, I need to know the determinant of the N matrix. So for instance, determinant of N1 for IA is the matrix that I get when I replace the first column with the right-hand side, the first column with my B vector. So the first column here, I will just write down 100 and minus 40. So that's from the right-hand side of my system of equations. And then I copy the rest of my matrix. So I'm just reading it off from here, and I will get a minus 10 and 15. To evaluate this determinant, again, I will use the diagonal products. So that is 100 times 15 minus 10 times minus 40. And that evaluates to 100 times 15 minus 400 bear with me, sorry, 100 times 15 minus 400 is 1100. Then for evaluating IB, I need to know the determinant of my N2 matrix. N2 matrix is what I get when I replace the second column. So I'll read off first column from A matrix, so that's 14 minus 10. Second column I will read off from the right-hand side of my system of equations, so that is 100 and minus 40. Determinant of this system is the diagonal product, so 14 times minus 40 minus 100 times minus 10. And again, we'll just calculate 14 times minus 40 minus 100 times minus 10 is 440. So now all of the work is done. I can basically write down that IA is determinant of N1 divided by determinant of A. So that is 1100 divided by 110, which will just be 10 amps. And IB is determinant of N2 divided by determinant of A. Determinant of N2 was 440 divided by determinant of A is 110, and that will just be 4 amps. So then finally what I need to do is go back and express this in terms of the variables that I was asked to solve for, which of course are currents I1, I2, and I3. And so I already calculated here that I can read off I1 and I2 directly as IA and IB. Finally, for I3, I just need to calculate IA minus IB. So I'll just go ahead and do that. So we had that I1 is equal to IA, which is 10 amps. We had I2 is equal to IB, which is 4 amps. And then finally we had I3 was IA minus IB, so that is 10 minus 4, which is 6 amps. And that's our answer. So to summarize key points when we apply the mesh current method, so we label each of our meshes with a current. So for here we've called them IA and IB. So these are currents that proceed in a circular direction. I've used clockwise directions around my meshes, and then we do KVL. And the main point to be aware of is when you have an element such as this resistor, which is shared between two meshes, that we need to write Ohm's law for both. It's kind of the sum, it's the combination of those currents. And so we have positive or negative signs depending upon which way round those arrows for the currents have been drawn. So that's kind of the small details that you need to pay attention to in order to make this method work correctly.